This is the back side of the Module 6 practice quiz number 2. So number 7 says, a small square field is 25 feet long and 10 feet wide. So we have a square. That's not a square. Rectangle. What is the length of a diagonal of this field? Answer with the correct units in simplest radical form. So we have a small field. Let's draw that. 25 feet long and 10 feet wide. What is the length of the diagonal of this field? So the diagonal goes straight across. Answer with the correct units in simplest radical form. So we're talking about feet, and if this is feet, 10 feet, this is also 10 feet down here. Sorry, I didn't draw that to scale. So what we made is a right triangle, though, that we can use to solve for this diagonal. Let's call it x. So when we have a right triangle created, we can use a squared plus b squared equals c squared to solve for any side. So c is the longest one in the hypotenuse, which is opposite the right angle. So it's going to be x. And a and b can be 25 and 10, either one. 25 squared plus 10 squared equals x squared. So 25 squared is 625, plus 10 squared, which is 100, equals x squared. Add those together. 725 equals x squared. How do I get just x? How do I undo the square? I take the square root of both sides. So I get x equals, that doesn't have a perfect square root, but I know that it's divisible by 25. It ends in 25, and 25 has a perfect square root. So I say 25 times, I'm going to do 725 divided by 25. It's 29. So I have the square root of 25 times 29. I'm going to move my work over here. Square root of 25 times the square root of 29, that's x. Square root of 25 is 5. Square root of 29, there isn't one, so I leave it like that. So 5 root 29, and we're talking about feet. That's your final answer. Number 8. Solve the following equations, box your final answer, answer in simplest radical form. So don't give me a decimal approximation. Leave it like we did up here with a radical. So we have the square root of 2x plus 9 equals 5. We need to undo the square root to get this stuff out of it to get to x. So to undo it, undo a square root, we square both sides. So the square root of this squared is just what's inside. 2x plus 9 equals 5 squared, which is 25. To get x alone, I'm going to subtract 9 from both sides. And 2x equals 16. Divide out 2 to both sides, and x equals 8. Number 9, I have a cubed root. To undo a cubed root, I need to cube both sides. The cubed root of x minus 1 cubed, let's cancel each other out, I get x minus 1 equals 4 times 4 times 4. Remember, that's not 4 times 3. It's 4 times itself 3 times. That's 64. Add 1 to both sides, so x equals 65. Number 10, I meant to have this be a plus, so you can change that. X squared plus 576 equals 625. So to get the x squared alone, let's subtract 576 from both sides. And we're left with x squared, bring down the equals, 625 minus 576. That's 49. How do we undo the squared x here? You take the square root. The square root of x squared is just x. Square root of 49 could be positive or negative 7 to get to 49. Remember to box your answer. And number 11, x cubed equals negative 27. So how do you undo a cube? Well, you take the cubed root of both sides. The cubed root of x cubed is just x. The cubed root of negative 27. Negative 3 times negative 3 times negative 3. So your answer is negative 3. Number 12, use the distance formula to find the distance between the points. Answer in simplest radical form. So our distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. You need to memorize that. So I'm going to label my points over here. This is my first x and my first y, second x, second y. So we can plug those into our equation. Distance equals the square root of x2 minus x1. So x2 minus x1, that's 4 minus 5 squared, plus y2 minus y1. So 7 minus negative 3. Be careful with those negatives. So we have the square root of 4 minus 5 squared, that's negative 1 squared, plus 7 minus negative 3. The minus negative turns into a plus, so that's 10 squared. The square root of 1 plus 100, the square root of 101. In part B, same equation, I have it written up here, but I need to label my points, x1, y1, x2, y2. Now, it's really important to label these so you don't mix up the numbers and get the wrong answer. It's very easy to get a wrong answer here. So the square root of x2 minus x1, that's negative 2 minus 4 squared, plus y2 minus y1, negative 9 minus negative 2 squared. Negative 2 minus 4, that's negative 6 squared, plus negative 9 minus negative 2. Remember that minus negative turns into a plus, only if they're right next to each other here. Negative 9 plus 2 is negative 7 squared. Square root of negative 6 squared, which is 36, plus negative 7 squared, that's 49. So we get the square root of 85. Now I want to see if that's divisible by anything, just to see if I can get it in a simpler radical form. So I try 85 divided by some of the perfect squares. So divided by 4, we get a decimal. 85 divided by 9, we get another decimal. 85 divided by 5. So the factors of 85 are 5 and 17. That's not going to help us at all, trying to simplify it. So we're just going to leave it as a square root of 85. Number 13, find the two missing side lengths. So we have two sides given and we're finding one. This is perfect for the Pythagorean theorem to help you find the side lengths of any right triangle. The one that's C, that's a really important one that's opposite the right angle, that's going to be 10. And A and B don't really matter, so let's have A be X, and 6 can be our B. So if x squared plus 36 equals 100, I'm going to subtract 36 from both sides to get this x squared alone. X squared equals 64. You need to undo that square and take the square root of both sides. So x equals 8. And it's not plus or minus because this is a distance, so we're not going to say the side length is negative 8. It's just 8 is going to be our missing side length. And for the second one, again, Pythagorean theorem, a squared plus b squared equals c squared. And the important thing to know is what c is. What's the hypotenuse? What's opposite the opposite the right angle? That's 14. And a and b can be y and 7. So y squared plus 49 equals 196. That's one of the ones you memorized. To get y squared alone, I'm going to subtract 49 from both sides. So y squared equals 196 minus 49. I get 147. I got to undo the square here to get y alone. I'm going to take the square root of both sides, so y equals the square root of 147. I don't think that has any factors. I could check real quick. 147 divided by 9, because that's a perfect square. We get a decimal. 147 divided by 4. 147 divided by 7. Oh, it's 21. So I have y equals the square root of 7 times 21. I can break down 21 to be 7 times 3. Remember, under a radical, when you see a group of 2, you can bring that out. So that's 7 root 3.